This was a question sent to me. So I'm doing this by request. The very first thing that you're going to do when you deal with a question like this is you need to draw. So the very first thing we're going to do is we're going to draw this diagram. Okay. So we need to look at two things. We need to look at the equation, which I've underlined, and then the restriction, which I've circled over there. So I'm going to draw a cast diagram. C-A-S-T. Again, we know this is 0, this is 90, this is 180, this is 270, and this is also 360. Okay, there's my cast diagram. So if I look at my restriction over here, right? So if I look at the restriction, it tells me that I'm going from 90 and I'm going until 270. So 90 starts here, 90 all the way to 270. That's all that space. So which quadrants meet the requirement of my restriction? The second and the third quadrant. So now I'm going to look at this first statement over here, and I'm going to go do some manipulation. So it says 2 sine theta is equal to, so I'm already subtracting the square root 3 on both sides. So it's negative square root 3. Get rid of the 2, so I'm going to divide both sides by 2. So now I have sine of theta is equal to negative square root 3 over 2. So the only thing that I'm interested in now is the fact that I'm dealing with sine and I have a negative, sine negative. So what I'm going to do is back at my cast diagram, I'm going to think which of these quadrants has sine as negative. So the third quadrant and the fourth quadrant has sine as negative. So when I look at my equation and I look at my restriction, the quadrant that satisfies both of those is the one that's got the 2 ticks there, my third quadrant. So now I'm going to just draw my third quadrant over here. And I'm going to draw a line in my third quadrant. And I know that this line, or that coordinate rather, that dot, it has a x, a y, and a r value. The r value is the length. So we should already know in our Cartesian plane, sine of a certain angle, let's call it alpha, cos of a certain angle, and tan of a certain angle is equal to, and then we have another formula. I'll put it there at the bottom in a second. So we should know sine is y over r, cos is x over r, and tan is y over x. So if we have sine, which we do in this question, we then know that this is y, and let's say that this is y, and this is r. Okay, so in this quadrant, I'm going to have my square root 3 there, which is y, and r, which is 2 units. Okay, let's say r equals. The only problem is we in the third quadrant, so that's at the bottom. And if I'm in the third quadrant, I need a negative y. So the negative that we had there, this will have to be a minus square root 3. We need the x value. So the other formula is x squared plus y squared is equal to r squared. So we're going to use this one in order to find our missing x value. Okay, so we'll say, I'm going to write over here, we're going to say that x squared plus y squared is equal to r squared. So we know what r and what y is, so let's go sub those in. Y we said was negative square root 3, and r we said was 2. So x squared is equal to, well, x squared plus minus 3 squared, that's going to give us positive 3, or rather the square root of 3 squared is going to give us positive 3, is equal to 2 squared is 4. So I want x alone, I'm going to subtract 3 on both sides, so I'm going to have x squared is equal to 1. Now what I need is I want to get rid of the square, so I'm going to do square root on both sides, but we should know that when you do square root, plus and minus are both options, so it's plus and minus. So my solution is going to be, I'm going to write it over here, x is equal to either plus or minus 1. We are going to take minus 1 because we are in the third quadrant, we're at the bottom. So we need a minus 1, we're at the bottom and on the left. We need a minus 1 to put me in that quadrant. So once I've got x, y, and r, we can go answer any of the questions that follow. So 411 is cosec of theta. Okay, so let's say cosec of theta is equal to, now we should know that sec is the reciprocal function of sine. Okay, so if sine, earlier we said sine was y over r, cosec would be r over y. Okay, let's check again. What was our r value? Our r value was 2. Our y value is square or negative square root of the 3. So it's 2 over negative square root 3. That's the first part. The next one was cos. Okay, so we already from our ratios that we have, we know cos of our angle, well, it's a theta in our question, cos of theta is equal to x over r. X you said is -1 and r is still our 2. And then the last one was sine times 10. So sine theta times 10 theta divided by, right, let's see, divided by cos theta. Okay, so this is what we're going to do. Sine is going to give me a ratio, tan is going to give me a ratio, and cos is going to give me a ratio. What's the ratio for sine? For sine, we know it is going to be y over r. Our y value is square root or negative square root of 3. Our r value is 2. Tan was y over, so still y minus square root 3 over x, which was -1. And cos we have there as -1 over 2. And thus, I don't mind if you go put that in the calculator. We just want to be able to see that you can come up with the ratios. Okay, so let's do this quickly. These negatives are going to become positive, so we have another negative there and another negative there, so everything's going to reduce positive. Square root 3 times square root 3 is going to be a positive 3, and 2 times 1 is 2, and this gets divided by a half, and that is going to give me just 3 as an answer. Okay, that's that. What I will say is make sure you know these ratios off by heart. Okay, know them off by heart, and then the only thing you need to do is be able to figure out which quadrant you're in. So how did you find the quadrant? You looked at your equation, you got it into standard form, and then you said, okay, we're dealing with sine, positive or negative, which quadrants? And then also you looked at your restriction, and based on the equation and the restriction, you picked the quadrant, you found x, y, and r, and then you solved the rest of the question. Okay, good luck.